Okay, well, welcome. As I said, my name is Chuy. I'm originally from Mexico, and I've been working at Dappnode for almost a year and a half. What's really cool is that I started using Dappnode as a user, and then I started getting more involved in the project, but mostly out of needs at the user level. So by the time I approached them and said like, hey, you need like some support and you need like some community management and stuff like that, I pretty much had already like found a need not only for myself as a user, but also for the project. So one thing took to another one, and then during the first year I was there, I was a community manager, and I'm now part of Dappnode as a node ecosystem lead. And well, we talked to a bunch of other projects that support infrastructure in one way or another, so that we can have integrations with Dappnode. So we'll talk about that in a little bit. But the first thing that I really wanted to know about this audience is going to start with 3 questions. And I'm going to take them like from a more advanced level to a more basic level. Don't worry, we're not going to leave anyone behind. We're going to be catching up with the different layers of complexity that this topic has. But okay, who in the audience has experience operating blockchain nodes? Okay, 1, 2, 3, 4. Okay, that's really good. Who thinks that you need 32 ETH to run an Ethereum node? Be honest. Okay. Okay. And who doesn't know what a node is or anything that I'm talking about? Like, who has absolutely no experience in blockchain infrastructure, which is also, come on, feel free to, okay, cool. So, as I said, don't worry, we're not gonna leave anyone behind today. And let's dive into it. So, nodes. What are they? How did they become like such a big deal in the Web3 ecosystem? So let's go back a few years. Most of us know the story behind Bitcoin. Most of us know that Satoshi Nakamoto is actually not this guy, but just a pseudonym. It can be one or many people. And also, Satoshi Nakamoto is known because of their contributions to the Bitcoin project, especially in the very early stages. And something that I really love about the story of Bitcoin is that Satoshi didn't really come up with anything new. He just like mixed a bunch of stuff that already was like spread around. Like, for example, blockchain was something that, if I'm not misremembering, I think the New York Times came with it, and it was because they wanted a cryptographic relationship between every one of their prints of their newspapers. So if you looked at the side of each of the printed editions in that time, there was like some kind of barcode. But what it really was is that it was like a cryptographic connection between every edition. So one would verify the one before it, and so on. And also, proof of work as a consensus mechanism. It actually, 2 investigators from Stanford came up with it, I think around '94, and it was a mechanism to prevent email spam. So what Satoshi Nakamoto really did is that he found a bunch of different like isolated solutions and brought them together to form Bitcoin. So the way he solved double spending or transactions being, like duplicate or abused in Bitcoin was by constructing a network of different nodes that validate information with each other. So the idea was called the Nakamoto consensus. And what this basically is a way in which the blockchain will not move forward and will not confirm transactions if it's not by verifying with the rest of the peers. So let's say that the same way everybody here has heard about like torrent technology, for example. So the way you know that you are downloading one file, and that specific file only is because of a unique, let's say, like, forgot the word, of a unique, like, yeah, like a fingerprint. Yeah, thank you. A unique fingerprint that this file has. And if you change one single byte in that file, the whole print will change. And there's no way in which people cannot contribute by participating, sharing a torrent if it does not match this unique fingerprint. So the way Satoshi Nakamoto solved this issue in the Bitcoin network is by creating a relationship between all of the participating nodes. So to put it in a simpler way, a node is just a copy of the blockchain. If you have a Bitcoin node, you have a copy of the history of Bitcoin. And if you have an Ethereum node, it's the same, but in the Ethereum blockchain. So this is what Bitcoin looked like the Bitcoin Core client. It was like a pretty easy, application, and it allowed you to use the Bitcoin network. However, it had a built-in node so that it could verify the transactions that it was both like receiving and sending. You can actually see the progress here. Like if you try to start to sync Bitcoin Core till this day, it's going to give you like a nice timer that says I'm behind, 13 years, I think, like since Genesis. But yeah, it's going to give you an estimate in time about like what point in time it is syncing on. So it was really cool. And what I really like in what I think is a very beautiful idea that Satoshi Nakamoto had was that by verifying each of the participating nodes in the network, you could provide security. Not only because you participate in block production, which is a whole different topic. Like that's why one of the questions I asked first was who here thinks that you need 32 Ether to start an Ethereum node? No. You need 32 Ether to run a validator node. And for running a validator, you're going to need like a fresh copy of the blockchain. So the same thing happens with Bitcoin. If you want to be able to propose a block to the network, you need a sync node. And what I love about this vision that Satoshi had is that everyone participating in the network as a node could play a lottery every 10 minutes, every time the Bitcoin network adds a new blockchain to its chain, a new block to its chain. Then people would be playing a lottery to see who is the one that solves a mathematical puzzle so that they can propose a block. However, this idea quickly died because of greed and because we are human. Someone realized that if you provide additional hash power to the network, you're going to have more chances of proposing a block than anybody that is using a lower amount of hash rate. So then it just became more human. You know, it's like, oh yeah, let's bring like all of this electricity, and the idea got a little bit corrupted. You know, like it wasn't, the original idea was not to compete for who has the largest amount of hash power, but it was to have a lottery between the participants in the network. So you can see how, you know, like the human factor sometimes kind of like deforms technology and its original intention behind it. However, we did have some learnings. Out of this idea and out of this phenomenon, some discussions started to arise in the different Bitcoin communities that were developing the technology back then. So someone, for example, proposed that, you know, like instead of putting a lot of electricity, what if you put some stake, or what if you put some participation? So it would be the same, but instead of acquiring hardware to compete for this, you would be staking some funds. And this way, we can come up with a less resource-intensive way to maintaining a blockchain working as it should. We're going to talk a little bit more about consensus mechanisms in a little bit. But what I want to where I want to get with this example is that this relationship started working in a very circular and balanced way, because there was a relationship between the users of the Bitcoin network and the nodes operating or providing access points for users to participate in receiving or sending transactions. And there were also the block proposers, which were the miners. The block proposers needed nodes and were providing a way in which users can get their transactions confirmed as soon as possible. So I think that even though human greed kind of ruined the party for everyone, I also want to bring up some of the lessons that we came up with after these first years of Bitcoin. So what I want to get, where I want to get is the world had never seen before a monetary coordination layer that was trustless and that was permissionless. So even though most of the stuff didn't work as expected, we were still discovering new stuff. And that was interesting enough for many actors to start improving and adding up to this ecosystem. So let's concentrate in only one of these three elements today, nodes. And this whole infrastructure and these kinds of technology works thanks to nodes. So everyone okay so far? Any questions? Okay, great. So let's go back a few years before Bitcoin. The 90s internet. The 90s internet was a wonderful place. You took 39 years to download a file. You had this kind of, picture and propaganda, and you had AOL. I don't know, if you were in the United States, you probably received 100 of these CDs for connecting to America Online, which was not really the way the internet was meant to expand, but we'll get back to you later. And then Shakira, who was capable of writing great music, also was using the internet to store some of her lyrics back then. And then, what I love is that people during the 90s had this visual image of the internet as many computers connected together in a network. And if if you turned on the TV and the internet was in the news for some reason, someone would ask, but what is the internet? They were like, oh, it's this network of computers around the world that are connected together. And I think that was a really, really cool idea. But unfortunately, 20 years later, that's not what we ended up with. We ended up with this dystopian infrastructure of centralized and concentrated information in just a very few participants. We ended up with governments being able to lie to the population. We ended up with governments being able to surveil the population. Pretty much everything that, films like Terminator and The Matrix warned us about. We ended up with media focused in releasing the truth to the public being repressed and being just prosecuted. And also 50% of the companies that make up NASDAQ are basically in the hands of this huge conglomerate of our information. So this wasn't really the idea that the internet promised. And we switched our visual image of the internet from many computers connected together to a server. And this is a good excuse for anything, whatever you want to get to work doesn't work, and it's, oh yeah, the server is down, or this service is down, or whatever. You go to a store and I don't know, somebody doesn't want to work, and it's oh yeah, my system is down, oh, I can't connect to my server. And that's probably because we built infrastructure not in the best way for scaling it and to avoid falling into these mechanisms of control that governments have. So our structure needs to change if we want different results. And the importance of relying on decentralized infrastructure is becoming more important every day in many areas, not only financially and not only socially. So a really cool solution is to run your own node, but the problem is that this is what running a node looks like. And it's a highly technical process that kind of sucks, and you know, like, I don't know, I remember the first time I tried to run a node, and I was like, no, this is probably not for me, because even if I'm successful at running a node, it's gonna be very challenging to keep it working as intended. So if we talk about technologies that have the potential to change our realities, and then this technology is sustained by you putting your money to work under a node, this is very scary. Like, I would never put my money into like an interface that looks like this. It's just like not meant to scale for everyone, right? So this is where Dappnode comes in. So what is Dappnode? Dappnode was founded in 2018, and it's a free open source software that originated from the recognition of a significant barrier in the blockchain ecosystem, the difficulty of running one's own node due to the technical complexity and the need for constant maintenance. So Dappnode's mission is to provide an easier way for node operators to get involved and get benefits out of running a node. Validating is just one of those benefits, but there are many things that you can use a node for, especially if you're a developer. So again, what is Dappnode? Even simpler, Dappnode allows you to run validators and other nodes with very few clicks, privately, on your own hardware, and without any technical knowledge. Dappnode comes in two flavors. We sell plug-and-play hardware that you get to your doorstep. You just plug it into the internet, into the power, and that's it. Or you can also download our software and just flash it to a USB. And if you have experience installing operating systems in the past, it's just as easy. We have an unattended installation that will take care of everything for you. You don't have to enter like no settings. You just plug in your USB, and after 8 minutes approximately, the installation is going to be done. You can restart the device, and it's going to be running Dappnode. So how does Dappnode look? This is what the interface looks like. You get a dashboard with the different clients that you're running, and it shows you if they are synced, how many peers it's connected to, and the block number that is going through. You get a Dapp store where it's basically just the same as your Android or iOS app store, except that we have a permissionless Dapp store. So anybody can publish a package for Dappnode without it being permissioned by Dappnode. You get a stakers menu where you can spin up a Cholesky testnet node, an Ethereum mainnet node, Gnosis Chain, or Luxo, just by selecting one execution client, one consensus client, a remote signer in case you want to load any validator keys, and also run MEV Boost if you know what that is. But maybe we can save that one for the questions. But we made this like so intuitive that it's like so easy. Even if you try to select two execution clients, if you click on this, then on this, like it'll unselect the first one. Like we made it pretty much I don't want to say, I don't want to say foolproof because it's like, but noob proof. Let's put it in noob proof. Like with myself being a tech noob also. And also, like, if you like, if you like logs, you can also get like the logs. Like we don't restrict you from getting access to, like under the hood and what it looks like. And this is what the staking brain looks like. This is where you load your validator keys. So Dappnode does not handle any of your validator keys. Like we do not help you generate anything. Like Dappnode is a machine that is supposed to be plugged into the internet 24/7. And as you know, it is not safe to handle private keys or anything like that if you are connected to the internet. So we just provide a very intuitive interface so that you can import any key stores that you generate for validators. So why Dappnode? It's great for non-technical users. It's open source and it's also free. We have a permissionless SDK, as I mentioned. we have some built-in cool stuff like VPN and IPFS. It's optimal for proof of staking from home. Runs great on Intel nukes. Like people love nukes because they are very powerful machines that are pretty much just like another. It's even like a little bit bigger than, I don't know, like an Apple TV or some home appliances that you might have. And we also have an amazing community of people that support each other and help each other if they run into any trouble. So let's do a quick demo of Dappnode. Give me a second. Okay, cool. So now I'm connected through VPN to Dappnode that I have in a virtual private server, but this one, for example, is back in Mexico at home, or this one is at home here in Barcelona. So you have remote access thanks to VPN technology. And this is one that I have loaded in a VPS. So as I said, this is the dashboard. You get Wi-Fi in case you're running it from a local device. You can also have Wi-Fi as its main access method. This is where you set up the VPN profile. This is the Dapp store also. Let's say that I want to spin up a Bitcoin node. So I'll just select the Bitcoin package, click on install, and that's it. I don't have to do anything else, and it'll start syncing on its own. And once it's ready, I'll be able to use it as a local Bitcoin node in my network. Here are the packages that are currently installed. The stakers menu that I mentioned, as I said, like it's pretty like nuke-proof. And if you select like MEV Boost, you can select different relays that you want to that you want to make work with your validator. We also support rollup technology, so you can spin up like so far an Optimism node, but we're very close to releasing a node for CKEVM. And Dappnode, in order to maintain itself decentralized and permissionless, we rely on two technologies that are very good at this. Ethereum is the first one. So the Dapp store, what you see as this catalog of different packages is actually a repository and a smart contract in the Ethereum blockchain. So anybody that wants to publish that, they just need to write in their IPFS hash that is storing the package. So this way, and also using local IPFS node, you can always have access to the Dapp store. It doesn't matter if like the Dappnode servers are down or anything. Like it's not the way that Dappnode was built and shaped. Like we wanted it to work even if the Dappnode team was like compromised in any way, either socially or technologically. So this is how you get to pick your repository. In case there's something wrong with your local nodes, you can always switch to remote and use the gateway of your preference. You can have, you can adjust auto updates. You can set up notifications. You can also, this is a Linux-based operative system, so you can always, run update and upgrade. Or if there are any Docker updates, you can always also check what's the status of your most recent Docker instance. Community just will give you links to our different platforms. And we also have like this SDK that will help you publish different packages. And we have a support tab that will help you know what's wrong in case something isn't working, something is working unexpectedly. Usually when we are in the community and you are having some kind of trouble, the first thing that we're going to ask for is a report. So you can generate system reports with this very simple. You can also check the status for ports. Some of mine are closed right now. Probably have to fix that. And you can also see a general log of the different activities that you've been running at your Dappnode. So, oh yeah, and also you get like updates. I'm testing this package, but updating them is easy as if you have automatic updates enabled, they will trigger 24 hours after publishing, just to give it room in case there are any like hot fixes released. And also, yeah, you just like click update in case you want to like manually trigger, and that's it. So, yes.
Do you support Lightning nodes?
We used to have a package, but I think it's not currently maintained. But you are still able to see it in the public repository.
Okay.
So let's look it up. I think it's somewhere here.
Repository is like something that you audit, or?
Yes, the DNP is a more like curated repository, but yeah, like other than yes, we also maintain that repository, but yeah, kind of like maintaining Dappnode packages. Sometimes it's tricky, especially when they start stacking up. Mm-hmm. This is why we've made some partnerships with different clients. So in the case, for example, of the Nethermind client and the Lodestar client, they publish their Dappnode updates themselves. So most of the time, whenever there's a Nethermind update, you just have to wait like for an hour, and they'll publish their Dappnode version right away. So this is something that we're trying to do with other clients, especially because of the bandwidth that the team has right now. So it's kind of like a cool side to it, but at the same time, you gotta like, sometimes you gotta take teams by the hand, you know, and show them how to properly update their packages. But the idea is that they don't need from the Dappnode team to be able to publish and maintain their packages. So this was the case of, I don't see the Lightning Network here, but it's probably, yeah, like propagating or something. Yeah, here it is. But yeah, it probably got lost in, you know, like the IPFS dark forest, but it's very easy to go into the GitHub repository and just, you know, like use the SDK to generate it again.
Okay. And also, do you support, I mean, well, two things.
Mm-hmm.
I assume that this is something like Dockerized, no?
Yes.
In the sense, if I install your software in a Beefy machine,
Mm-hmm.
I can like try to sync a Bitcoin node and an Ethereum node altogether.
Yes.
Okay. And also, when you set up a Bitcoin or Ethereum node, is there any way to configure the settings of the node, in the sense if I want like an SPV, for instance, for Bitcoin, or I don't want an archive node of Ethereum, is there the possibility to do that?
Yes. By default, all of the Ethereum clients will get you a full node. But if you want an archive node, you can either install Aragon, or you can also go to the package. And let's try it with Besu, for example. If you go to the config, here you can have like an advanced editor, and also, you know, like add some flags if you want to like modify the gas settings or stuff like that. Okay. As far as, you know, like exposing it to the network goes, you have the querying API in case you're using VPN or it's in your local network. Or let's say that you want to share your Ethereum node with family and friends. You can go to the network tab, and you can do an HTTPS mapping of it using DNS, so that you can share it with people that are not part of your network. That is like the most, that is the optimal way to share your node with friends and family. But yeah, try to not make it public, because if not, you'll probably get too many requests and it'll make your client crash. But yeah, I mean, it's something that we can, yes?
You can finish your sentence. I just had a question. Yeah.
No, it's just something like that we try to make it as easy to do as possible.
Yeah,
so
it's
yeah.
really easy, and so that's my point. Suppose in 3 clicks I can run a Bitcoin node on my computer. Then what's the benefit I can expect? Will I start being paid by the Bitcoin network for validating transactions, or something else? Yeah.
Great question. It's not in the case of Bitcoin. Why? Because Bitcoin is a proof of work network. What you can do is that if you are solo mining, which is a concept that is pretty much dead in Bitcoin. If you are solo mining, you can use your Dappnode, your Bitcoin Dappnode to, verify the blockchain in real time with your solo miner. But I would say that this is maybe a little bit more easier to make an example of in the Ethereum side of things, because there are a lot of people, and we're going to talk about that, like about client diversity and staking pools and centralization a little bit more in when I get back to the presentation. But yeah, there are still a bunch of people that do solo staking in the Ethereum network, which has its benefits. But for some reason, you can still stake your Ether in Lido, and it's going to give you a better API than if you go solo validating. So there are still some challenges and some negative aspects of some centralization factors that come into this.
What kind of computer resource is it asking? Do we need a powerful computer, or
it's
you can do it with an old computer that's sleeping in a corner?
I would encourage you to, if you have any kind of old laptop laying around or anything, try to install Dappnode on it and see how it works, see how far it gets you. Because it's just better to try it in an easy way, and maybe, I don't know, your laptop had a hard drive instead of an SSD, and it wasn't fast enough to keep your client synced. But the only way you're gonna find out is by trying it out, so that can get you started on your first experiences as a node runner. And then if you want to actually run it on a functional system, I would recommend any quad-core CPU. Can be Core i3 to i9. It doesn't really make a difference whenever you're not syncing. The CPU's hard work is when you are syncing, but once that's done, there's not a lot of CPU activity. RAM memory, 32 gigs, 64 optimally, and disk, this is pretty relative because it depends on what you want your node for. If you want an Ethereum mainnet node, 2 terabyte won't do. And a year ago, it wasn't like this. But because of all of the of the upgrades that Ethereum underwent, 2 terabytes started falling short for running a full Ethereum node. So if you want to run an Ethereum node, 4 terabytes, but you can still run with 2 terabytes, Gnosis Chain or Luxo or a testnet. It depends. Bitcoin, I think it's 900 gigabytes right now, or maybe 800, something like that.
I managed to run on the 2 terabytes hard drive, so now the SSD.
Yeah. So also the cool thing about Bitcoin is that since it adds a block every 10 minutes, you can pretty much run it at any kind of storage. It doesn't need to be fast, like the Ethereum one that is every 15 seconds, of writing and reading from the node. So yeah, those are kind of the basic. Okay, so let's get back to this. Whoa. Yeah, wait. Okay, so okay. Okay, so after this commercial break, let's get back to some of the challenges of decentralized infrastructure and Ethereum. So some of the things that didn't really go well for Bitcoin with the passing of the years were mining pools, because it concentrated the hash power in very few entities. So there's this thing called the Nakamoto coefficient, which is basically a number that tells you how many entities in different contexts, but how many entities you need to compromise in order to perform an attack to the network. So in the case of Bitcoin, it's not looking well, because if you have just a few of these and these two, you can probably 51% attack the Bitcoin network, which is something that would be catastrophic for all of us. So Ethereum is maybe not doing that well, but probably much better than Bitcoin. Why is this? Because even though 30% of all of the staked Ether is in the hands of Lido, we still have a big chunk of the pie that is mostly solo stakers. So solo staking or home staking is known as like the gold standard because it's the best way in which you can support the network, even though it might not be, like economically as incentivized as participating in a big staking pool. And there is a reason for this. But at the same time, I think that that technology should like dog food its own solution in many ways. So this is what some of the protocols are doing. And even though like anybody with 32 Ether can become a validator for the Ethereum network. But what if there was a way in which we could separate these two concepts that are like so tied together, like the 32 ETH holder and the node operator? What if one could serve another? And through smart contracts and through the same technology, we could find solutions that would benefit Ethereum decentralization. So I feel that right now there's a very interesting chapter going on, and it's mostly around node operators and the way that they can help the network decentralized. So let's imagine, like nodes, validating nodes in the Ethereum network as a gradient with emerging properties. So you have one node, which is a centralized system because, I don't know, let's say that this node is yours and you're the one that controls it. But then you have two nodes and you have very basic data redundancy, but you can already, like make a comparison between one and the other. And then you have nodes in different locations, which can develop resilience to natural disasters. So what if there's a hurricane going through my city? And then I have like power outages. So then you talk about nodes in different power grids, which are resilient to power outages. And then you have nodes in different political jurisdictions. In case the government interferes, you can become resistant to this with different nodes in different jurisdictions. Nodes in different hardware. What if Linux pushes like some kind of update that doesn't really get along with the drivers on your hardware? And the cool thing is that some of the nodes are using Raspberry Pis and some other are using nukes. So this also contributes to resilience. Then we go to different clients. What if there's a bug on Geth or on Nethermind? And what if which has happened in the past actually? And it's very interesting to see because Ethereum uses multiple clients by accident. And because there were like so many egos in the early stages and they were like, no, I can make the better client. No, I can make the best client, and it was because of this that accidentally they came up with client diversity, which has been a really cool thing, especially after some episodes where things don't turn out as well for the Ethereum protocol due to bugs present in clients. And then you have system-specific properties, like how many validators are you running in one single node? What's your bandwidth or your ISP? Maybe we have 3 different nodes, but they are all using the same ISP, and then the ISP arbitrarily chooses to ban traffic for Ethereum nodes, and like all of these differences starts to contribute to a big picture of diversity. And as diverse, let me rephrase that. The blockchain and the protocol will only stay as resistant as its diversity lets it be. So the similarity gives resilience against common mode failure. So we were talking about the Nakamoto coefficient. So let's talk about the state of Ethereum decentralization. Anybody knows what the Nakamoto coefficient is for the Ethereum blockchain?
Well, I checked, I don't know.
No, it's okay.
3 or 4 months ago, but
Okay, so as I said, the Nakamoto coefficient is the amount of entities required to compromise the network. And if we put it in a geographical context, that number is 2. Because it would only take for the United States and Germany to outlaw validating in Ethereum to heavily compromise the network. This is why diversity and geographic locations, it's also becoming very, very important. Because even though it's present in 85 countries, you can get more than 50% of all the validator, all of the block producers in Ethereum, just by banning it in the US and Germany. So we're still not there, but there's a lot of room for improvement, which is what becomes exciting. What are some of these improvements? Let's talk about liquid staking derivatives, or LSDs. Wow, that's a token, not a derivative. But yeah, LSD is also, a fun way to put it. You have protocols like Lido or Rocket Pool or Stakewise, who have come up with decentralized and permissionless ways to deposit your Ether and to make it work in block production. You also have distributed validator technologies, or DVTs, which are becoming a very, very popular topic right now. Why is this? Because you have diversity of clients with many nodes working on split keys. This means that if you have one validator, you can split it between different participants, and no one will have the full key for that validator. So you have to cooperate with other nodes operators to stay online, which is something very attractive for these protocols right here, who have become monsters of their own. Like Lido, for example, with 30% of staked ETH. That's a very, very huge vulnerability, because Lido, up until last year, used to put all of this trust for 30% of the staked ETH in the hands of 37 operators. So only 37 nodes were operating this huge pool of ETH, these billions of dollars in security. So there's something wrong there, and there's something that needs to be fixed. And it was very easy to criticize Lido last year, because they got a lot of shit from people, because, it's irresponsible, you should hard cap how much your pool takes. But no one wants to do that. I mean, even if you staked ETH in Lido, there's a reason for that. And it's because Lido is offering you the best returns, because by pulling all of the rewards together, you create these incentives, which is something that I think the Bitcoin network couldn't really get over in the past. But then if you distribute the trust of operating this between different operators, thanks to solutions like Oval Network, like SSV or Diva, then you're talking about resilience, even if people pull together their resources to get the most out of it. So this is a way in which we are redefining this relationship that we talked about in the beginning. And I think that when I say that separating the concept of the 32 ETH holder from the node operator is becoming like there's an increasing distance between those, it's exactly because of this. Because maybe half of this room has a technical experience and ability to operate a node, but maybe the other half just has a shit ton of Ether that you want to get some returns on. So let's make protocols that keep a healthy network, and that can also create alternative relationships between node operators with no money, with people that don't want to operate nodes but that have a lot of money. So just doing a quick recap on today's talk, nodes are important for a healthy network. The greater the number of nodes, the better the chances to verify blockchain interactions. Block production is one of many things that you can run on top of nodes. So if you don't want to run a validator, if you want to run a Noble cluster because you want to, you want to just like spin up a validator on a testnet because you get together with a few of your friends that are also node runners, and you all want to be able to provide node operating services to a staking pool. Or maybe to your local community. Maybe go and open a new Stakewise vault and make your friends and family deposit there, and then instead of trusting only one node operator for it, you can split the responsibility between different node operators. So then if you get like a natural disaster, a power outage, there's a way in which you can still deliver to the people that are trusting you with their stake. Dappnode is an easy way to run your own nodes, as you said. Like we skipped like that whole technical thing and went straight to, like pick your clients, get your configuration going, and spin up your own nodes. So it provides a user-friendly UI. It's free open source software, which has been challenging, but we're very happy to be here today. It's in constant touch with the ecosystem and its developers. And you can also help the Ethereum blockchain by running your own nodes, get together with more node runners, see what you can build together, and build resilient infrastructure. So yeah, you gotta choose which meme you want to be, like between these two, but you should always choose become a solo staker, support the network the right way. There's just like no loss in exploring new and different ways to participate in block production. So, okay, my name is Chuy. I'm the node ecosystem lead for Dappnode. I don't have any Zuckerberg social networks, but you can find me on Discord with this handle, or you can also find me on Farcaster. I'm on Farcaster. I don't post that much, but and if you want to find out more about Dappnode, you can visit our website. You can check Twitter, and you can also join our Discord, which is our main support platform. And it's actually our only official platform, so please don't listen to anyone that DMs you. All of the support, we keep it within the boundaries of our Discord. We have a user base that has a lot of money most of the time. And we encounter a lot of users that just bought a bunch of Ether a few years ago and never looked back at it. And then they're like, oh, I might become a solo staker, but they haven't really stayed in touch with the ecosystem and with security practices. So it's always good to, whatever you want to try, always try to keep it within the boundaries of the support, the community that you are asking supported. And yeah, thank you so much to Web3 family for doing these awesome events that give us the opportunity to share this knowledge with all of you. And yeah, I think that's it. Thank you very much. Questions? Yes.
Yeah, I saw that you could also run rollups on top of it,
Mm-hmm.
and I kind of interested in trying to run a base node.
Mm-hmm.
What would that take? And if you support it or?
It's not that we support it or not. Our approach is chain agnostic. But as I said, one of the challenging things for the Dappnode team is keeping up with so many packages and their maintenance. So someone could just grab the Optimism repository and clone it and make it work for base. But it's not something that we do at the moment. It would be very easy to do. But the challenging thing would be to maintain that package, because they get, especially rollups that get upgrades very constantly as they improve their stage. That's the main reason why we haven't diversified a lot on support for rollups. But yeah, pretty much it would take the same thing as the Optimism node. So if you want to give it a shot, please, stay in touch with us. Yes? Absolutely. So the way it works would be, let me show you. Okay, so let's say that, I have a Cholesky testnet node here. So normally you would go to MetaMask and add the Cholesky network, but you would be accessing a public RPC. So the only difference is that as long as you stay in the same network as the Dappnode, you go to Cholesky Vesu and add this querying API as your RPC URL in MetaMask. That's the only difference. You would change the URL from your MetaMask network settings, and then you'll be using your own node. Actually, it's really fun to submit a test transaction and just go and look at the logs and just see what's happening below the hood. So yeah. This is the only thing that would take to submit transactions using your own node. Oh, and as I said, let's say that you want to share this node with friends and family. The best way to do that would be to go to network, and then you can add a new HTTPS mapping. So let's say that I want to open this to my friend Peter, and I don't want to set a user or password for now. So I would add the mapping, and that will expose this to the internet. So I'll just take that public URL, and they will have to change their network settings in their wallet providers to use this as RPC URL. Yes. Yes, and this is for people outside the network. But if you want to use it with, like inside the network, you just use the querying API, and it's the same. Yes?
In your experience, 2 or 3 nodes of different blockchains can coexist on the same Dappnode?
Yes. Yes, really good question.
Gnosis and Ethereum.
As long as you can store it, yeah, I think storage is probably the biggest challenge there because blockchains get big so fast. But then, you know, like from time to time, I come across operators that have enough storage, but they have 32 gigs of RAM. And they are like in the yellow zone like all of the time, and that may cause, you know, like some unexpected issues. So if you want to be completely safe, you can add 64 gigabytes of RAM, and I've seen people run up to 4 different networks in the same Dappnode. Like it's up to the specs that that your hardware allows you to get. Yes?
You can set up an Ethereum node with Proof?
It depends on each client's features, but yes. It's also like, for example, we have some people that tell us like, oh, I have 4 terabytes, but my disk is almost full, and I've been validating nonstop for 2 years. What's wrong? It's probably because they use a very like old database version of their execution client. So what we regularly recommend is for them to get rid of the database, and then Dappnode will take care of just resyncing back. And it'll download a newer version of the database that most likely supports pruning. So we try to make everything happen as automatically as possible and as intuitive as possible. Like for enabling pruning, we don't even require users to, you know, like add the flags. We just add everything by default for whatever's most convenient for non-technical users.
How long it takes to set up a Ethereum node?
It also depends on your client. If you use, for example, Nethermind can be synced in like 3 to 4 hours. It's kind of, it's received a lot of criticism because you're only working with the headers instead of, you know, like the whole database. And Nethermind allows you to do that. But for example, Geth will take,
So it doesn't check all blockchain, just download the last blocks.
in the case of Nethermind, but if you download Geth or Besu, it'll take you 2 to 3 days to fully sync. And if you get Aragon, which is an archive node, it'll take up to 3 weeks. Like Aragon is insane. I don't know anybody that runs Aragon. But you know, like some devs especially like to have an archive node for different reasons. So then Aragon would be their flavor. Anybody else? Any other questions? Okay, cool. Thank you very much. And if you have any other questions, please don't hesitate to approach me and we'll talk about it. And yeah, thanks Adrian again for this amazing event, and see you next time. Yeah.